Question 7 students. In the given figure, in triangle ABC, DE parallel BC, if AD is equal to 2.4 centimeter, DB is equal to 4 centimeter and AE is equal to 2 centimeter, then the length of AC is, options are 10 upon 3 centimeter, 3 upon 10 centimeter, 16 upon 3 centimeter and 1.2 centimeter. So now here let us we write first the given information, that is there is a triangle ABC. So here in triangle ABC the given is DE parallel to BC. DE parallel to BC. As the DE parallel to BC, then we can use the theorem as basic proportionality. Okay, basic proportionality theorem. So now here students, that here this theorem we can use it, we can call it as BPT. So BPT theorem. So by BPT, we get the ratio, that is AD upon DB is equal to AE upon EC. AE upon EC. Now substitute the values. So AD is a 2.4, DB is a 4 centimeter and AE is a 2 and here EC. Then first we calculate the AC. So by cross multiplication we have 2 multiplied 4 divided by 2.4. So that means we simplify 2 multiplied 4 multiply 10 upon 24. So now here 4 ones are 4 6 are. So here 2 ones are 2 3 are. So that means students here EC is equal to 10 upon 3. EC is equal to 10 upon 3. Okay. So that means the EC is equal to 3.3 centimeter. EC is equal to 3.3 centimeter. Now here students we have to calculate the AC. So here AC is equal to AE plus EC. So now AE is a 2 centimeter. So 2 plus 3.3 and that means 5.3 centimeter. So such a way you can find out the length of AC by the basic proportionality theorem. So here students, our correct answer, yes, our correct answer, that means English form students. Okay, so now here students see, that is AC is equal to, so 10 upon 3 plus 2, that means 10 plus 6 upon 3. So here 16 upon 3. Okay, in the numerator and denominator form we can get this also, 16 upon 3. So student, the correct option is C, 16 upon 3 centimeter. Question 8 students, the perimeter of a right triangle is 60 centimeter and its hypotenuse is 25 centimeter. Find the lengths of other two sides of the triangle. So here students, as per the given information, we first draw the figure and here it is a right angle triangle. So here I draw the right angle triangle. So it is right angle at B, okay, and name it as triangle ABC. So now here hypotenuse is AC and the given hypotenuse is 25 centimeter. So I write here 25 centimeter. So as per the given information, try to solve this example. So here students, in right angle triangle ABC, in right angle triangle ABC, apply Pythagoras theorem. Apply Pythagoras theorem. So by applying the Pythagoras theorem, we have the equation, that is AC square is equal to AB square plus BC square. Okay. So now AC square, that is a 25 whole bracket square, which is equal to AB square plus BC square. So that means here 625 is equal to AB square plus BC square. Okay. So that means AB square plus BC square is equal to 625. So now here we can call it as the first equation students. So now here there is another information given, that is the perimeter of the right angle triangle is 60 centimeter. So that means here students, AB plus BC plus AC is equal to 60 centimeter. Now here students, that is AC. AC is a given. So here AB plus BC plus AC 25, which is equal to 60. So AB plus BC is equal to 60 minus 25. Therefore, AB plus BC is equal to 35. And call it as the second equation. Okay. So now here, students, I square both the sides of this equation. Okay. Squaring both the sides of this equation. So now here, squaring equation 2. So now I get that AB square, sorry here, first write that AB plus BC whole bracket square is equal to square of 35. So now here AB square plus BC square plus 2AB multiply BC is equal to 1225. Square of 35, that is 1225. So now AB square plus BC square. See here students, the equation 1, that is a 625. So 625 plus here 2AB multiply BC 1225. So here students, 2AB multiply BC is equal to 1225 minus 625. So AB multiply 2AB multiply BC is equal to 600. So AB multiply BC is equal to 600 upon 2. So students, AB multiply BC is equal to 300. Okay. So now here students, we write this as the third equation, call it as the third equation. Okay. Now here students, we have the expansion of AB plus BC whole bracket square. Okay. So now here that AB plus BC whole bracket square is AB square plus BC square plus 2AB multiply BC. And then again here that I expand the AB minus BC whole bracket square, and the answer is, expansion is square of AB plus square of BC minus 2AB multiply BC. So now here I subtract these two equations. So I got AB plus BC whole bracket square minus AB minus BC whole bracket square is equal to, now here AB minus AB square, that is 0, BC minus BC square, that is equal to 0, and here plus 2AB multiply BC and plus 2AB multiply BC, and that means the 4AB multiply BC. So now here students, that AB plus BC whole bracket square, see here AB plus BC whole bracket square, and that is equal to 625. So here students, AB plus BC, okay, 1225. So I write here AB plus BC whole bracket square 1225 minus AB minus BC whole bracket square is equal to 4. Now here AB multiply BC, that means a 300. Okay students. So now here further we solve it as here that 1225 minus AB minus BC whole bracket square is equal to 4 multiply 300, that is 1200. Okay. So now here students, 1225 minus 1200 is equal to AB minus BC whole bracket square. So that means here 25 is equal to AB minus BC whole bracket square. Now the 25 is the square of 5. So here square of 5 is equal to AB minus BC whole bracket square. Now squaring on both the sides students. So 5 is equal to AB minus BC. So here AB minus BC is equal to 5. So now here students, AB plus BC is equal to 35. So that means here we can write AB is equal to 35 minus BC. Okay. So now I put here that 35 minus BC is equal to 5. So 35 minus 2BC is equal to 5. So here minus 2BC is equal to 5 minus 35, which is equal to minus 2BC is equal to minus 30. So 2BC is equal to 30. Cancelling out the negative sign on both the sides. So BC is equal to 30 upon 2 BC, that means which is equal to 15, which is equal to BC is equal to 15. Okay, that is a 15 centimeter. And what about the AB? That AB is equal to 35 minus BC, that means 35 minus 15 and that is equal to 20 centimeter. So AB is equal to 20 centimeter. So now the AB and BC are the other sides of the right angle triangle ABC and that are found. Question 9 students. The perimeter of an isosceles triangle is 32 centimeter if each equal side is 5/6 of the base. Find the area of the triangle. So now here we have to find out the area of the triangle students, and for that we know the formula for the area of the triangle, that is the half into base into height. So that's why we have the length of the height as well as the length of the base. So we try to first finding out both, that is the base and the height. So let us, how can we find out that the base and the height? Okay, now we are special type of the triangle and that is the isosceles triangle. We know that the isosceles triangle, that means the two sides are equal. So now here, this is the isosceles triangle here students, and these two sides are equal. I call it as triangle ABC. Then here the condition is that base of the base fits upon 6 base. So I consider that this base as a, then automatically the AB and AC, that is the equal side, will be fit 6A. Okay, here also fit 6 of A. Okay, now here the given that the perimeter is 32 centimeter students. So first we finding out, that is the triangle ABC. In triangle ABC, perimeter is equal to AB plus BC plus AC. So now here 32 which is equal to AB. AB is the 5.6A plus BC is the A plus 5.6A. So now here 32 multiply 6, multiplying both the sides by 6. So here 6 multiply 5.6A plus 6A plus 6 multiply 5.6. Here 6 multiply 5.6A. Okay, then here 6 get cancelled, here also 6 get cancelled, and here it is a 2 and 192 is equal to 5A plus 6A plus 5A. So that means here 192 is equal to 10 and here 16A. So here students 192 upon 16 is equal to A. So that means 16 ones are and 16 twos are 32. So A is equal to 12. Okay students, we got the base, that is A is equal to 12. Now students, the next one method, the next one step, that is the BC is equal to 12 centimeter. Then we can say that we can find out AB as well as the AC, and that is equal to 5 upon 6A, that is equal to 5 upon 6, that is a 5 multiply 12 upon 6, and which is equal to 6 ones are 6 twos are, that means equal to 10 centimeter. So here AB is equal to AC is equal to 10 centimeter. Okay students, so now here that our job is to find out the base. Okay, to find out the base. So now we have the base, that is A is equal to 12. Okay, but now the finding out the height. How can we find out the height? So that's why we construct this figure as perpendicular. Drawing the perpendicular here, that suppose AD perpendicular to BC. Okay, AD becomes the height and BC is the base. So now here students, that is the here we have to find out the AD. So that's why the BD and DC here construction, that is a figure. Here we can say the both the AD, BD and BC are equal. That means here A upon 2 and this is also A upon 2. BC is equal to A upon 2 and we have to find out the height. So with the help of Pythagoras theorem, we can finding out the AD. So here in triangle, in right angle triangle, we call it as in right angle triangle, that is in right angle triangle ADC. ADC. Here applying applying Pythagoras theorem. Okay, applying Pythagoras theorem. So here we say that AC square is equal to AD square plus DC square. So AC square that is a 10. So here I write square of 10. AD square that we have to calculate. So write down as it is AD square and the DC square, and the DC square is A upon 2. Students, A is equal to 12. A is equal to 12. So 12 upon 2, that means it is 6. So I write here square of 6. So now here 100 is equal to square of 80 plus 36. So then here 100 minus 36 is equal to square of 80. Okay, students, then here then 64 is equal to square of 80. Then here 64 is the square of 8. So I write square of 8 is equal to square of 80. That means 8 is equal to 80. And then we can write here 80 is equal to 8 centimeter. So now here students, we have the base and the height. So here we can use the formula area of triangle ABC is equal to half into base into height. So now here students, that is a half into base. That base is the A, that is the 12, and the height that is the 80, and which is equal to 8. So now here 12 multiply 8 upon 2, that means 2 ones are 2 fours are, and 12 fours are 48. So area of triangle ABC is equal to 48 square centimeter. So such a way we can find out the area of the isosceles and isosceles triangle. Is question 10 students. If a line drawn parallel to one side of triangle intersecting the other two sides in distinct points divides the two sides in the same ratio, then it is parallel to the third side. And state and prove the converse of the above statement. Okay, so now this is a statement and we have to prove the converse of the above statement. Okay student, so now here this is the basic proportionality theorem students, and we have to prove the converse of the basic proportionality theorem. So here first we try to write down the statement, the converse statement of this statement. Okay, so now here the statement will be, okay, first I write down the statement. That is the first two sides in the same ratio, it is parallel to third side. So here in any triangle, if the segment segments of the segment of the two segments, other two sides, we write other two sides of the triangle to triangle, then we say that here then the ratio formed by these two sides are equal. Okay, so this is the converse statement. Then here first we draw the figure as per the given statement. So here we consider this is the triangle ABC. Okay, and then that in any triangle the segment of the other two sides, So now here that other two sides, suppose that there is a D, point D on the line, on the segment AB, and there is a point AC which is on the segment AC. then draw this segment. Okay, so now here that DE parallel to BC, and then we have to prove that AD upon DE is equal to AE upon AC. Okay, so still students, we write here that given that in triangle ABC, DE parallel to the BC here, and then that is D is the point on the line segment AB. And here we say that E is the point on the line segment AC. So we can write DE parallel BC here. And then we have to prove, that is to prove that AD upon DE is equal to AE upon AC. Okay. So now here from the figure we cannot prove this. Okay. So there is a construction, and that construction is that we join the line segment DE. Also here we join the line segment BC. Okay. Then here that now we have the two triangles, that is a BDE and CDE. And that BDE and the CDE are the two triangles which having the same base but a different heights. So here students, first in the proof I write that first thing, that is in triangle BDE and triangle CDE, I got the ratio, that is area of triangle BDE upon area of triangle CDE is equal to BD upon, here I say BD upon AC. Okay, that is called as the first equation. Then the second one, that is I take the triangle ADE and triangle BDE. I choose these two triangles. Now here the ratio, their area's ratio, area of triangle ADE upon area of triangle BDE. So if you observe these two triangles, then here they have the same height, students. They have the same height. So their bases, we got the ratio of their bases, that is the AD upon BD, and call it as second one. Then next one, I choose the triangles, that is in triangle, I write in triangle ADE and triangle CDE. So now these triangles are also ADE and CDE. These triangles also having the same height, and so their ratios of areas of triangle, that is area of triangle ADE upon area of triangle CDE is equal to their ratios of bases, that is AE upon EC. Okay, that is called as third one equation. So now here students, from equation 1, 2 and 3, we conclude that, here says, we have to write here, that is we have to prove that AD upon DB is equal to AE upon EC. So now here that we write this area of BDE upon area of CD, that is BD upon EC, and here BD upon EC. So now here students, from these equations, we have said that as BD upon EC, AD upon BD and AE upon EC. See here is the AE upon AC. That is the ratio of this second side. Okay, and AD upon DB, that is the ratio of this first one side AB. So now all these three are equal and we have said that the AD from 1 to 3 from 1 to 3, that is the area of triangle ADE similar to triangle BDE and similar to triangle here CBE. Three triangles are similar to each other. So now here their ratios of sides are equal and that we have AD upon BD which is equal to AE upon AC.